This is our DHT22 sensor and this is the LCD as you can see. Now you can see that 3 digits, left 2 digits are the integral part and the third digit on the right is the decimal part. So temperature is 30.4 degrees centigrade and humidity is 40.6%. I use the heat gun to increase the temperature, so that's why it has gone up. Now again I use the heat gun to change the temperature and the humidity value. So this is a heat gun. See, the temperature has started to rise and the humidity has started to fall. See, now it's 40 degree, 44 degree and the humidity is falling. Now temperature is 46, humidity is 29, temperature 47. See, it is rapidly rising because the heat gun is set to 480. See, the temperature has risen to 48 and humidity has fallen. So guys, this is it. That is how it is gonna work. Hello guys, welcome back to learning microcontrollers. In this video I'm going to show you how we can interface a DHT22 temperature and humidity sensor with a PIC16F877A microcontroller using MikroC for PIC programming. And then guys, we will be displaying the output on 16x2 Lm016 LCD. So we will simply be modifying a code from one of my previous videos, that was the DHT11 sensor video, and then I will show you how you can modify that code to run that on this DHT22 sensor as well. So let's get started. So guys, as you can see, this over here is the PIC16F877A microcontroller having 40 pins. It's a DIP variant. It is also available in the SMD variant as well. You can use any other PIC as well depending upon the pins available. Now guys, on the left side is the DHT22 sensor. It is very easily available in the market. It is just like DHT11 sensor, but the difference is it has a bit of different command structure to fetch the data. It is mostly the same, but it has more bytes. Like you have to fetch the data in 2 bytes rather than 1 byte. Now guys, the other thing is it is more accurate. It is a better version of DHT11. So I will make a video on the difference between DHT11 and 22 soon. So let's right now do the connections. So as you can see, the center pin is the out pin, that is the signal pin. The bottom one is the 5 volt positive. The top one is the ground. The maximum you can give is the 5.5 volt. Don't exceed 5.5 volt. Now guys, let's connect it with the PIC. You can connect the signal pin to any available digital input output pin of the PIC. I'm going to use a pin number D0, that is pin number 19. Now for the power pin, connected to the VCC pin of the PIC. For the ground pin, connected to the ground pin of the PIC. In this way, this module is connected to your PIC microcontroller. Simple as that. Now guys, for the output, we are going to use the 16x2 Lm016 LCD. As you can see, it has 16 pins from 1 to 16 if you hold it like this from left to right. Now guys, what we do here is that we will need a potentiometer to connect this with a PIC. This will be used to adjust the contrast of the LCD. Now guys, let's do the connection. As you can see, this potentiometer has 3 pins, 1, 2 and 3 mentioned on its body as well. And for the LCD, it is 1 to 16 from left to right if you hold it like this. Now guys, connect the pin number 1 and 5 of the LCD connected to the pin number 1 of the potentiometer. Then you send it to the common ground. In this way, your LCD gets a ground and your potentiometer gets a ground. Now pin number 2 of your LCD, 3 of your LCD is the contrast adjustment pin. You will connect to the adjustable pin of the potentiometer. From this, you will adjust the contrast of the LCD. And this is the pin number 3 of the LCD connected to the pin number 2 of the potentiometer, or any pin, whichever potentiometer you use should be 2. Now whichever potentiometer you are using, remember that it must be like 10K is most suitable for this LCD. Now guys, for the power, you will connect the pin number 2 of the LCD with the pin number 3 of the potentiometer, then you send it to the VCC of the PIC. In this way, your LCD gets the 5 volt and your potentiometer also gets the 5 volt. Now guys, pin number 4 of your LCD is the RS pin. You can connect it to any available digital input output pin of the PIC. I am going to use a pin number 15, that is pin number C0 like this. Now guys, pin number 6 is the enable pin. You can use any available digital input output pin. I am going to use the pin number C1 of the PIC. Now guys, pin number 11 is the data pin 4 of the LCD connected to any available digital input output pin. I am going to use a pin number C2. Similarly, for the data pin 5, that is pin number 12 of the LCD, I am going to use the pin number D2 of the PIC. For data pin 6, it will be D3. For data pin 7, it will be C4 like this. Now guys, pin number 15 and 16 of the LCD, they are for the backlight. If your LCD have a backlight, only then you will connect these two pins, else you will not connect these two pins at all. My LCD do have a backlight, so pin number 15 is the VCC, 5 volt for the backlight, and 16 is the ground. Now these 4 pins 7, 8, 9, 10, they are for the 8-bit mode, while we are using this LCD in the 4-bit mode. In this way our connections are completed. Now what we are going to do is that we will program this in such a way that our LCD will display temperature like this. On the first row it will be temperature equal to whatever the temperature value is. On the second row it will display that it is displaying the temperature, and you can see that it is 307. This means that first 2 digits are the significant digits on the left of the decimal, while the third digit is after the decimal, so it is 30.7. I will be using this format because it is easy. So it is 30.7 degrees centigrade. Now similarly for the humidity, then it will show one by one, first temperature, then humidity, then it will keep on repeating like this. And for the humidity, RH equals to 644, it means that it is 64.4. First 2 digits are the decimal to the left of the decimal, and after third digit and onward it is to the right, so it is 64.4%. Simple as that. Now guys, let me introduce you to the hardware before we move on to the programming. Guys, this over here is the hardware. This is our 16x2 LCD, and this is our DHT22 sensor. On the left you can see that it is a DHT22, and this is the LCD, and behind you can see that is our development board that I just made a trainer, that is the PIC16F877A. Behind it is the PIC3. Rest is just a trainer board, so our concern is only the DHT22 and the LCD and the PIC microcontroller. So guys, this is the hardware. So let's move on to the programming now. So guys, this is the MikroC for PIC version 7.6.0. I will share the link to the video in which I have told you how you can download and install this MikroC for PIC for free, full and no crack or anything like that needed. It's a full free version from the official website. So let's first of all, what we do is that we need the code from our previous video. So we go to the Google, just go to the Google. Okay, I go to the Google, then I go to the YouTube, and in the YouTube I go to the channel Learning Microcontrollers. I will share the link to the video directly in the description as well, so you don't have to go through this. Okay, there it is. Now in the videos here we have a video on it. Just write down DHT11 in the search bar. It will lead you to that video. So this is with the Bluetooth, no, oh this one interface with the LCD. So there is the full video here. So just click on this so we can see the video. Okay, now go in the description of this video. In the description of this video, just open it. Here, go down. Let me zoom out so I can see better. So here we go. In the description here you have this link, Google Drive link to MikroC for PIC files. Just click on it, open it, and here we have the MikroC for PIC file. Let me zoom out. So this, just download it. Let it download. These are the MikroC for PIC files for this videos. We will just take these files and modify them for our project. Okay, here we go. Let me open the folder. Just copy the file where you have downloaded to some suitable place where they will be easy to access. Just paste it in some other folder, make a temporary folder, paste it inside it, extract the files, and this will extract this MikroC for PIC folder. Now you just go to your MikroC, and here in the MikroC click on File, Open, and then go to the folder where you have just extracted that folder. Here look for new folder 5. Okay, here it is, double click on it. So here you go, this is the code. Now before you anything else, because see the debugger is not working, copy this code, new project, click on next. Here again DHT22 tutorial by learning microcontrollers. Okay, that is the name of the project I wrote. You can write any name you prefer. 20 megahertz is the crystal. Click on next and finish. Okay, before you do anything else, first of all save your work, press Ctrl S. Now paste the code from that tab to here. Okay, it is pasted here like this. Now guys, see the libraries we are going to use in this. So you have to select the libraries again. There is a conversion library, then we have the LCD library. Now we click on build to see if we are correct. Okay, now this have been a problem for the other guys as well, because in the previous version of the MikroC it worked like a charm, but in the newer version it is making an error. So to overcome this error, also for the DHT11 as well, you just rename them. I make it RB12 and now press Ctrl F and search for RB1 wherever it is. Again make it 12, wherever it is just make it 12. Again RB1. Okay, make it 12. Now again RB1, and if it is found again, now again make it 12. Now again search for RB1, just rename it everywhere. Okay, again RB1. Okay, this is it. Now the other one which still gives error, now it's RB2, just make it 112. Okay, now search for RB2. If there is any other, just make it 112, 112. Again now search for RB2. Now again make it 112. Again search for RB2. Okay, no RB2 is found further. See, so that is it. So these two were making problems for the DHT1 guys as well, the 11 guys as well. So you can simply do this to remove the error, that's all. Now I build the code, see no errors. Now what we do is that now we need to modify this code for the DHT22. If we run this as it is, you will see that only one character will be displayed, not both. So I go here at this place, and here you can see that we have temperature TB1. After this checksum, we need to do the modifications here. What we do is that since we were taking only one byte, this is one byte and this is the second byte. See, now we will combine them. I will combine both, because in the DHT22 you have a problem that if you display only one byte, it will be just one digit. It will not be the whole decimal less integral parts. So to make sure you get both the parts, you have to combine them. And now to combine them, that's a simple C syntax, how you combine the low and high byte. You simply do is that, let me write the command here. Now this is our TB1, only the temperature we will taking. Now we will not take the temperature. What we do is that temperature equals to, I make it TB1. Now this is a standard condition. I will shift the TB1 by 8 like this. Then I will apply the or TB2. That's all. Now that's how you will combine. Whenever you need to combine the low and high byte, then that is what you are going to use. Now this is the low byte, the first byte, integral part, and this is the decimal part. I combine them using this command TB1, the integral part, and TB2. It is shifted by 8 to the left, and then the right side we have the decimal part. That's all. Now guys, do the same for the humidity as well. This is the humidity here. Now for the humidity again, what I do is that I use bracket, shift it by 8 like this, shift this by 8 to the left, and or the second high byte, or sorry, the decimal part, RB112. Now that is it. That is it. This is how we are going to make it work. See again the low byte, or sorry, the integral part shifted by 8 to the left, so we can add the decimal part to the right, or then we use the OR condition and or the decimal part. That's all. Now to display it, we will display it one by one as shown in the presentation. So for that purpose, first of all, I make it 2 1. On the second row we will display the whole temperature. Okay, just keep it 1 1, and we add here the second row, so it will display the temperature on the second row, complete word called temperature, like this. Now as shown in the presentation, it will be temp is equal to, okay, that's fine, we let it be. Then we display the temperature, whatever the temperature value is. Okay, that's nice. And then at, okay, what is this? I think it was because having some error on the LCD, so we remove it. We will see if there is any rack back values, we will do the modification, because for this cheap LCD you have to do this. Now at 16 it will display the temperature, that's fine. Okay, now here as you can see, it is LCD temperature. First of all, we will display the temperature on second row, first column, and then after that, let me zoom in further, I hope you guys can see better. Okay, after that we will do the LCD out. We will display whatever the combined value is, temperature. Temperature is converted to a string in temperature 1, because we cannot display integers directly on the LCD. We need to convert them to a character or a string. An array of character is a string, and this is the string. Whatever was in this is now transferred into this in the form of string, and now this will be displayed on the LCD. And after displaying it, it will show C at the 16th column. It will start writing temperature from the 8th column, and then from the 16th column it will show C. Now I want the data to be displayed for like 1 second. For 1 second it will keep on displaying the data, and then the LCD should LCD will refresh. So the new data, that is the humidity, can be displayed. So go to the LCD library. Here you have this command LCD CMD. Go here, copy this command in the example, go back, paste it here below this. Now the LCD will refresh, like there will be nothing on the LCD. Now we will display the humidity. Just copy this here, copy all this till here, paste it here like this, and now start doing the modification. Make it humidity, and it will be RH equals to, and then we will display the humidity one, this character variable for the humidity, and then it will be percentage, because humidity is taken in percentage. That's all. And then again we will clear the screen, and now remove these because we just wrote its alternate commands. Okay, now what we did is that, first of all, temperature, we combined the integral and decimal part, then we converted this whole to string, then we displayed temperature on the second row first column, and then on the first row first column we wrote temperature equals to, and from the first row 8th column we wrote the data, and then on the first row 16th column we wrote C, that is Celsius, and then we will keep on displaying the data for 1 second. After that the LCD will go clear, and after that we will take the humidity, we will combine the decimal and integral part of the humidity. We converted this to a string, and then what we did is that on the second row first column we wrote humidity only, and then on the first row first column we wrote RH equals to, and then on the first row 8th column we wrote the data here, and then on the first row 16th column we wrote percentage, and then again for 1 second it will display this data, and then after that LCD will go clear. I built this code. Okay, it's built successfully. Remember that there is a possibility of some racked back values, then we will do something about that. First let's burn the code and see what happens. Okay, now let me turn on the PIC16 programmer tool. This programmer tool, I have a video on that, how you can download and install this as well. So I will share the link to that video in the description as well. Okay, now go to the file, import hex file. This is the file we just created. Double click, click on write. Okay, the new file is being written. Let's go to the hardware and see what happens. Okay, let it write the new file. The new file is being written, let it write. Okay, it's written successfully. Okay, the new file is written. I will power up the PIC using PIC3 programmer tool. Okay, it's powered up. Okay, that's fine. See, it is showing perfectly temperature equals to, for 1 second it shows a temperature, and then after that it shows a humidity. See, and then it keeps on, repeats the loop for the, because DHT22 and 21 sensor requires some time. So the temperature it is showing here is 227.3 and humidity is 53.2% in the room. Now see, with the behind the C there is a rack back value. Now go back to the MikroC, we remove this. You can see that there on the 15th column on the first row we see a rack back value. Rest is perfect. So let's go to the MikroC. That's what I was talking about. In this cheap LCD you have to deal with it. Now what I do is that I just make it like 15. I write this at 15 and give a space. So this is now the rack back value spot. Now it will be empty because I am writing it manually. So I can overcome that problem. Okay, I build this and I write this new code now to remove that rack back value. Okay, the new code is being written. Let me zoom out and let's get to the hardware. So on the hardware you can see that the new code is being written. Let us write the new code. Okay, that's perfect. You can see that the rack back value is gone now. Now we are getting the temperature 27.3 degrees centigrade and humidity 53%. Now I bring a heat gun in to change the condition. See, this is the heat gun I have here. I will be using this to change the temperature and other stuff. So I use a heat gun on the DHT22. See, the temperature is rising and humidity is also changing. It's now 37 degrees centigrade because heat gun is set to 473 and the humidity is falling. See, now again I bring it in front. See, humidity has fell further and temperature is 37, 44. Now it is rising further, 45 degrees centigrade. See, again I bring the heat gun in front and I warm up the sensor to see what happens. See, it is rising further and humidity is falling. See, it's 52. It's rising further, it's 61. Now I remove the heat gun and let's see, let the temperature fall. Now it will fall after it has reached its melting point. See, 67.2. Now it has started falling. Just wait. 67.4 and the humidity is now below 0. See, it's just 8.7, sorry, 8.3%. See, 8%. Humidity has fallen too much because of the hot air that we just blew into it using the heat gun. Now it's 7.8, it is still warm. See, the temperature has started to fall because I had removed the heat gun from front. See, it's now 65. See, it is working like a charm. It is working perfectly. So you can play with the code and you can make various other type of codes as well. You can use a different LCD, you can use the Bluetooth as well, and you can use any other device to display the output. So that will be a very good exercise. So, but your coding will remain the same. Now the temperature is rising, falling. I will pause the code so we can save time. Once it falls below 40, I will resume the code. Okay, let it fall. It is now at 59%, 59 degree, and the humidity has started to rise. See, it is working perfectly as per the charts. It is showing perfect output. See, 57 degrees centigrade and the humidity is now rising. 11%, 11.4%, 56 degrees centigrade, 11.8%, 55.5 degrees centigrade, 11.9%, 55 degrees centigrade, 12.3%, 54, 12.6%, 54 degrees centigrade. See, the temperature is now at 53 degrees centigrade. It is again coming back to normal. It was like 26 or 27 degrees centigrade in the room. You can see that it is continuously falling and the humidity is going back to normal. It's now 14.6. So guys, this is how you can use this DHT22 temperature and humidity sensor using the PIC microcontroller. It is a very effective sensor. So if you have any questions or comments, you can use the comment section. And guys, thank you very much for your time. It will be great for me to know if you guys learned something from this video. Thank you very much for your time, guys, and have a nice day. We'll see you in the next video.